A very good afternoon to everyone, and thank you for joining us for today's session on careers in astronomy. Career in astronomy is one of the very popular and most anticipated topic of every student. Today, to share more on this topic and probably help you to get more insight on this, we have Professor Ranjan Gupta from the Inter-University Center for Astronomy and Astrophysics, also popularly known as AYUCA Pune, with us. Planetarium welcome you, sir, for your kind cooperation and support in organizing this session. Professor Ranjan Gupta is PhD in physics from Physical Research Laboratory, Ahmedabad, in the year 1987. If we talk about his research training experience, from 1985 to 87, he was at Physical Research Laboratory, Ahmedabad. From 87 to 90, he was at Indian Institute of Geomagnetism, Mumbai, as upper atmospheric research. And from the year 1990 to till date, he is at Ayuka, Pune, working in the field of astronomy and astrophysics research and teaching astronomy to MSc students. Currently, he is consultant and head IGO Ayuka. His research and interest includes astronomical instrumentation, stellar physics, interstellar dust and extinction and its modeling, and neural network and its application to stellar spectra. He is also an active member of several prestigious committees, which include member of International Astronomical Union, member of Astronomical Society of India, member on technical committee of various planetarium at Mumbai, Nasik, Surat, Delhi, Pune, Bhubaneswar, Patna, etc. A recognized guide at Pune University, Guwahati, Rajasthan University. Member of postdoctoral studies in physics on Assam University, Silchar. Member of Board of Studies at Pondicherry University. Member of Scientific Advisory Committee for Positional Astronomy Center, Kolkata. In the past 25 years of his academic career, he got the opportunity to be part of several international collaborations and under these had spent various duration at USA, UK, Germany, Canada, France, Spain, Italy, Russia, Japan, Australia, and South Africa. He has a list of various publications and books written by him. It's a complete privilege to host you, sir, for this discussion at the planetarium. So we welcome you, sir, for this session.
Thank you, Prerna, very much for this introduction. Um, I have been, of course, giving such outreach lecture at several occasions, and I should tell you, I don't know the spectrum of audience, but at least this is more for students who are uh, thinking, or at least have planned to go for a career in astronomy. There will be various options which I will describe, and this whole talk is a PDF, so I will leave it with Prerna, and she can share with anybody who directly requests Prerna on this. So idea is that right from high school level, the interest grows in astronomy, and astronomy being a very popular subject, as most of the audience knows. um, what is the difficult part is that soon after BSc they somehow lose interest, or they get into other jobs and all. So we, as an institute who want to teach people in this, is basically ideally high school or even up to BSc. After that, really the interest wanes. So that is the right age where we want to catch them. And of course, there are different career opportunities, as we will see. A full scale thing is a PhD and then getting a faculty position in an institute or teaching in a university. But there are other branches where you can get into even place from where this is organized, the planetarium. In fact, the number of planetariums are coming up in the country. Some are getting upgraded. They need people who are ideally, BSc with astronomy background or MSc with astronomy background, particularly in the Patna where an upgraded planetarium is coming. So in Mumbai, which already has a very old planetarium, but they are upgrading to laser. I am into many of their advisory meetings. So they are basically looking for running not just the planetarium, but they will have a side thing like a telescope, like Nehru Planetarium, Delhi has, many others have, where you need a people to, teach the students how to handle a telescope. Any special event like comet or other things, they will have shows. So this is another kind of career which you can even think of. Uh, so let us start this talk, and I will share my screen. So people can see the screen now. This is the career astronomy and astrophysics.
Yes.
Prerna, the screen is there. Okay,
Yes,
thank
very,
you.
very much clear.
Thank you. So now this is just a small kind of thing which I will be giving today. One is the astronomy is one of the oldest subjects that, of course, many of you know. In fact, if you happen to have visited Pune and Ayuka, my institute, you will know that right from Indian old times, Aryabhatta was one of the prime. There is a large statue of Aryabhatta. You can go to Ayuka website and check that. So astronomy is one of the very old subjects. In fact, China also had a astronomy interest more than 1,000 years. And similarly, there's some of the Middle Eastern countries also have astronomy as a very old subject. And as I already said, it's of great interest to young and old from very early human times because they have been watching using naked eye. And even in the ocean, the ships used to use stars for navigating. The GPS came only in the last 40, 50 years. And many students really look for career astronomy, and which is why I am trying to give this talk. So let's see. Now, this is a slide which is somewhat smaller. So, Prerna, if you can zoom it, let's see if I can. Yeah, so it's not easy to read. What we can do is basically, I'm this since it will be sent to anybody who is interested, more details can be checked. But essentially, it's a single slide where many things are shown. Person using a telescope and things like that. So to brief you, the actual career opportunities can start right from 10th class. So 10th to 12th, you should have physics and mathematics obviously as a main subject. Okay. So once you are in 12th, you have physics and mathematics as main. Then either you will go to BSc with physics and mathematics, or you could even go to engineering line, the B, and then that will continue to MTech and so on. And you can ultimately, if you have to do an institute job, you will basically need a PhD. If you have to be a proper scientist, that means you have to have an MSc in physics and mathematics. So this is the most general thing, that right from school, if you think of physics and mathematics as your main interest, and then finally you can either go into institutes, you can complete your PhD from an institute or a university, and then go for a postdoc either within India or outside India, and eventually look for positions. So the positions could be, so this is where the postdoc is mentioned. It could be, in an institute where you do your uh, what you call as a faculty, you have to do some teaching and mostly research. Or in university, you can do still research, but main will be to do a teaching. Again, teaching will be MSc Astrophysics. And so there are more than 30 odd universities where astronomy is being taught, not just at BSc, but even at special paper as MSc. And one branch here is, as I just now mentioned, placement in planetariums. So again, mostly the qualification, at least we advise, is MSc, but there could be some things with BSc also. So there is another branch which I should tell you, again from PhDs or BSc and so on, is getting into industries. Now I should tell you, and you will soon see, there are many big projects which India is undergoing in astronomy particularly. There are other subjects also where they are actually looking for trained PhDs who are in astronomy. So just give you an example, two or three of such students from our institute, Ayuka, who did PhD and who did imaging in astronomy and studies galaxies. They were very good at the software tools. So some of these industries like Tata, Infosys, and others, they are actually doing many projects for India. In the sense, these mega projects, which you will see after a few slides, they require people who are fully trained in these subjects. And primarily, they are software projects. You all know how India is so successful in software for last so many decades. So they are actually looking for this qualification. That is another line of action where you can think of. So I guess this slide will be, of course, in a part of my talk. It's a PDF. So anybody interested will you should write to Prerna and she can forward you, but not to everybody. I think it's not going to be a nice thing. But people who have listened to this, they will appreciate if they get the talk. So let's move now. So, what do astronomers generally work on? See, there could be pure theory. They will be just doing theoretical modeling and they may not have any experience to actual data, or even for that matter, not even seen a telescope. They may be doing cosmology, modeling, but everything requires experiments. So, even if you propose a theory, you propose, I'm not even going to answer such questions on black hole, but say somebody has proposed a theory on black hole. But how do you prove it? Unless you have actually observed, unless you have actually seen the effects. So theory has a limitation. At the same time, with that background, you can at the best become a lecturer in a university, but your horizon really expands if you are an observational astronomer. So observations are very important. You can observe within India's telescopes. You will see very soon the kind of telescopes we have in India. Or you can use telescopes from outside India. And of course, finally, this is the ace that if you do all this and also you are developing some instrument for astronomy, then of course you are the top will be in demand. As I am myself an instrumentation person, I know that from my PhD days what is the demand. So I should insist that anybody who has engineering interest should go through all this. Eventually, since you have instrumentation background, you will be looking for such opportunity. In fact, all the mega projects which I will describe, the actual science, the actual theory will come only after 10 years, because these projects have just started. India is sharing money with other countries. When you actually see the data coming in, that will be after 10 years or 6, 7 years. So that is the time when the general theory and other people will be in job. But right now you're developing nuts and bolts. So this is the most crucial time when we need people right from grassroots. So in fact, any of these mega projects, when they are sanctioned by our government, the first question they are asked is, where are the people who will work on this? So that's why we all are looking for people who are showing interest doing, even before PhD, if they have instrumentation background, we'll be looking for engineers with these background. Even better if they have interest in astronomy and do instrumentation astronomy. Okay, so this is just kind of a repeat of what I was showing in that very compact slide. You will do undergraduate, postgraduate, and then you get a BSc. Either, so this is also an age group where you are around 22. You are doing an engineering and then MSc on this side, and ultimately you do a PhD, right? Around 27. These are the average ages. Just tell you, warn you that when you are in instrumentation development in your PhD, it's not easy like theory in 4 years you can complete and get a PhD and go abroad or whatever. Here you will be struggling with nuts and bolts, or things may not work, but eventually you will be successful. So usually this is a problem with instrumentation PhDs, not just astronomy, in any subject for that matter, whether plasma or anything, that the typical university rule of 4 years, 5 years is not enough. So they request for extension, and depending on the publications and so on, they usually get another year or so. But also the other thing is your publications in experimental PhDs will also be few. So I should tell you, my prime publication was in a geophysical research letter. I'm talking of 40, 45 years back when I did my PhD. But that was the main publication which came out of the experiment, which took almost 5 years to complete. So you should aim for that, that publication is what gives you job opportunity. So this is just a side thing I told you. Then postdocs, usually 30, around that. You will prefer to go abroad. In fact, I have been teaching MSc astronomy in Pune for last 30 years. I should tell you that the toppers, at least the top one or two or three, they always, and I also tell them that when they apply for postdoc positions outside India or where, they should not just stick to one and sit on that. See, things may not work. So you should at least have 5, 6 places where, if you are good, if you are topper and all, you will get calls from 2 or 3 places. Then the choice is in your hand. Okay, so that is the biggest advantage to apply various places. And I can assure you, all the toppers in the last 25, 30 batches are very well placed now. And those days they were either postdocs abroad, then they came and found positions in India. So that is where you can become a staff scientist or faculty. Of course, there is a branch of amateur astronomy, which also a lot of amateurs do, but then they have other interests. I mean, their main job is something else, but they contribute as an amateur astronomer. Where do the astronomers work? Mostly in institutes and also in universities. Okay, so we'll see pictures of some of these institutes where astronomy is the main uh, thing. So the first picture is my own institute, Ayuka, and this is just an open area, which is a kund, as it is called. This was basically the architect was Charles Correa almost 30 years back, and Professor Naldikar was the founder director. So I have spent almost 35 years here now, and this is one of the prime institutes where we have many programs. You can go to ICO site, just www.ico.in, and you will find a lot of opportunities for even school level students doing projects all the way up to MSc. Then let's see, this is the next door. This is the Radio Astronomy Center of Tata Institute of Bombay, where they are running a very large radio telescope, the largest in the world. I will probably have a picture of that. We are just, few meters across each other, right here in Pune University campus. So this is the main Tata Institute building. This is their, I think, accelerator building, and you can see the uh, Arabian Sea from here. So this, of course, has many other subjects like biology, but they also have a astronomy group. In fact, though, most of the Ayuka astronomers, not me, in those days, actually originated from Tata Institute, including Professor Nadlikar, who was the founder, and some others. And they formed this institute at Ayuka. Now, this is another one at Bangalore, Raman Research Institute. This is a very beautiful campus, and of course, it's named after Raman, who had the Raman effect. And this is also having, other than solid state physics, they also have astronomy. Then this is another major institute purely in astronomy, in University of Astrophysics in Bangalore. So Bangalore again has two major institutes in astronomy, and in fact, their university also caters to a lot of astronomy specializations. So this is another Indian, and many telescopes in the country are actually run by IIA. This is in Nainital, one of the older institutes. It's also mostly now more than 40 years in Nainital. It was earlier called the Uttar Pradesh Observatory, but now it is renamed and under DST called the ARIS. All these institutes have their website, so I urge you to go through them. You will get more details on that. Now this is, sorry, I went back, I think. Oops. Okay, and then apart from these institutes, there are now, of course, the new stream. You have ICERS, IITs have introduced astronomy. IISc also has astronomy, IISc in Bangalore. There are ISTs, NITs, and of course, as I said already, 30 odd universities give specialization, and even some colleges, autonomous colleges. Now, what are these observing facilities for astronomy? I am concentrating mostly on optical astronomy, but also I will show some radio astronomy. So this is I was mentioning, just 90 kilometers from Pune, is the largest radio telescope in the world, and it has about 36 such dishes. And it's an exciting place to see. It has four different frequencies where it works, and it can actually collect sources, very faint sources in radio. Then this is used to be the largest optical telescope in Asia. This is somewhat old. I went for the 25 years some time back, and this has a 2.3-meter optical mirror. Sorry, and it's a huge dome, and it is run by Kavalur. So Kavalur is between Bangalore and Chennai. It's on the hills. It's at about 750 meters. But since it is in South India, as you can already see, it has very few clear nights, because as for optical astronomy, you definitely need clear nights. This is the highest telescope as of now in the world. It is at Hanle. It is about 250 kilometers from Leh. All three sides are China border actually. This is a 2-meter telescope, very cold site. And you will notice that in the last few years, people have gone for shiny dome, because the white paint used to have titanium dioxide, but now they have found aluminum based paint reflects the daytime sunlight very well. So inside the dome is very cool. So that in the evening, when you open this thing, it very fast normalizes with the atmosphere around. Okay, so that was a tough place, but it's a working satellite telescope now. And notice that China is just 100 kilometer in Tibet on this side. This is north. where they have building at least 4-meter size telescopes. So sorry. So this is the IUCAS telescope at Giravali, which is 90 kilometers, similar to the distance of radio telescope. It's isosceles triangle. Again, you will see this is a aluminum-based dome. It is a 2-meter telescope. Uh, this is a picture of, so India now has the largest telescope right now. It is even bigger than the 2-meter, 2.2 meter uh, of Kavalur. This is 3.6 meter, and this is built by the Belgian company. And you can see this is the 3.6 meter mirror. This is some artist drawing, but it is working now. It's a massive telescope, and this is where India has participated in South Africa. This is a 11-meter telescope, and this is a nice picture in the night. This is a 11 meters, so it's really large. Belongs to South Africa, but India is one of the contributors. It has almost hexagonal segment because such a big mirror cannot be from a single piece of glass. So you will see these small hexagons nicely fit in, like our beehive, Madhumakhi, and they combine all this 91, make it a 11-meter telescope. So this has some restriction. It cannot move around too much in the sky. It's more of a transit, but with the size, it competes very well. At the same time, it is still a much cheaper telescope to make. Now, this is Ayuka's development. We have built what is called a robotic thing, which means now this throws a laser in the sky, and around 90 kilometers it makes an artificial star, a blob, and that light comes back to a telescope. So all of you know about the mirage and the twinkle twinkle little star, the nursery rhyme. The star, when you see in the night, is continuously twinkling because of the atmosphere. And Earth's atmosphere, if you go outside, of course, there is no twinkling. If you sit on moon and look at a star, it is absolutely a single point of source. So to avoid that, people are using some trick where they send this laser and it comes back, and you can sense the atmospheric changes, and then you can actually twist the mirrors. So it's more of detail. I'm just telling you. It's called active and adaptive optics. So on Google, if you just look for active optics or adaptive optics, you will find a lot of information. So this is something which we developed for a USA telescope of 60 inches. Now, this is another interesting. Can After becoming an astronomer, can you use the facilities abroad? Yes, under collaboration and various possibilities exist. I have myself used. This is right now not the largest, but it has four number of 8-meter size telescopes in Paranal in Chile, in South America. And you can see this is again a rectangular slit opening, and it's a cylindrical dome, and it has actually the aluminum paint. Why four of them? Because they can be combined, like our human eye has two eyes. In optical astronomy, also, if they behave like two eyes, any two can be combined. Then you can get a three-dimensional picture of the object, like galaxy or something. Now, a little bit about other subjects, because not just optical and infrared. This is our famous Nobel laureate S. Chandrasekhar, and named after him is this X-ray observatory. So X-rays can be used to observe, and the whole picture will be very different, of course. So, what are the new things which India is at least involved? So, there are list of these 4 or 5 new things which are mega projects. And mega, when I say, they are typically of the order of India's contribution is typically about 1,000 or 1,500 crores. Again, when I say this number 1,000 or 1,500, no developing country, although India is no more considered as a developing country, will not push it as through our Indian government pocket. We give $1,000 directly into 1,000 crores into a international project. So some part, most of it, 70% will be going to the industries, because we want the foreign exchange to be only a little bit. Most of it should develop. Our industries should compete. That is the logic for all the funding agencies. So yes, most of these things are developed within India. You will see some pictures of them. So let quickly. This is the 30-meter telescope. Now, when you see, when we were students 30, 40 years back, the 10-meter Keck telescope, 10-meter each in Hawaii, in Pacific, was coming up. So we will thought that how can you make a 10-meter telescope? Of course, already I showed you pictures, but for those days this was a dream, and it is coming true. Now they are already functional. So going for a 30-meter means there will be 500 such segments. It may sound very strange, but people are already planning to do this, and this is happening. Then another very interesting is the gravity wave. I'll just describe LIGO, where India is involved, and Square Kilometer. It's a large radio telescope which is coming up, and finally, it is the solar telescope launched by ISRO, just like the AstroSat. So this is a concept of square kilometer array in South Africa, and some of it will come in western part of Australia, two different radio frequencies. And actually, I have been to this site. You can see it's a total desert, and these there will be hundreds and thousands of such areas. But the area of this is probably, you know, maybe 30 meters. But total, if you multiply with the thousands of such telescope, it comes to 1 square kilometer, SKA, square kilometer array. So that's an enormous collecting area for radio astronomy. So this is another picture of that. Some of it has already started operating. This is another picture where in a desert you can see so many of them. This will go not just South Africa, some of the northern African countries also. So what is the advantage? Of course, it is saying 2020, but I think already some delays are there, but many of these are already operational. And there will be about 3,000 dishes. Each one of them, this diameter is about 15 meter. It looks just like your radio dish of your TV, but they are quite smaller because this is the wavelength is different. This is where the challenge is. You know, there is enormous amount. I don't know whether any one of you know what is terabyte, what this is petabyte. So that is the kind of data per year you have to collect, and not just collect, you have to process them. So the way the computers are also moving very fast hand in hand. Maybe these things are challenged, but that will also be handled. So the things called hexaflop computing and so on will happen. So now I was talking about the next large project which India is taking is 30-meter telescope. Now this is an artist picture. There will be open vents here for that air to circulate. This is probably coming in Hawaii, but there is still a doubt whether there are some protests going on there. But the plan, it will be there or in La Palma, which is in Atlantic. So this is where inside you can see just those 500 hexagon mirrors. This is 30-meter telescope where India is one of the countries, but there are China, Japan, Canada, and others. In fact, Japan already has a telescope of Subaru in 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 Hawaii, and they are contributing a little more in that. So different countries have been given resources for the 500 mirrors. About 130 or 140 of them India will make. Rest they will share, India and China. So this is the picture of primary mirror. There are 500 of these segments, and the actual field of view in the sky will be very small, 20 arc minute. Again, I am not going into detail. One arc minute is 1/60th of a degree, and it will study from ultraviolet to almost deep in the infrared. Okay, and it will also have adaptive optics. The next thing is, of course, space astronomy, and some of you know AstroSat is now completing its planned mission is about 5 years down the line. There are many. This is the first astronomy satellite, which pure astronomy satellite, which ISRO launched some years back, and there are X-ray and ultraviolet, and giving very good data from this. Now I'm coming to the gravity wave, which is a big thing now because in 2017 the Nobel Prize was given to these three persons, and the idea is that they have been running for this detection. Einstein's theory had to be proved, as I said in the beginning of my talk. Unless you prove it that such a thing exists, nobody will believe you. So finally, after almost 100 years, they could observe it. So that's the whole idea of gravity waves. And the challenge is this: you see this number 10 to the power minus 19 in 4 kilometers. That means there is a Michelson kind of a detector where four arms are there, and they are 4 kilometer long. And within 4 kilometer, you have to see a change in 10 to the power minus 19. Such a small change in 4 kilometers is just unbelievable. And if that change is seen, then you have detected. And that's why the talents took so long. Although the detectors were earlier there, but they were just below the detecting capability. So only in 2000, so the next thing shows, so here in 2000, 17 the Nobel Prize was given, and this is the detector, which is a sketch of this. So the lasers are bouncing on these two arms, and you have a detector here. And this is 4 kilometer by 4 kilometers. It's a huge thing. In fact, I have been to one of their sites. I actually observed in the night shift there. And so this is the place where I was in Louisiana, and there is a similar one in the northern US. They are 3,000 kilometers apart, and you can see one arm. This is 4 kilometers. The other arm you can see on this side. And I observed here for 7, 8 night events. They are of course 24 hours. So the interesting thing I should tell you, that was the time not in tsunami but little later. During those 15 days of my stay, there was a major earthquake in Andamans. Of course, not all earthquakes will give tsunami. And why it was major? Because detectors have mirrors which feel the shake, and they took 3, 4 days to stabilize. So imagine the sensitivity of these things. Now, India's contribution will be one more such detector, which has to sit on the other side of the globe. We are 12 hours apart. So, this is where Indian LIGO site, it is in the Buldhana district. It's about between Pune and Nagpur. It is somewhere midway. It's a very low industry site because we want very little noise and so on. And you can see already the village roads were there. So, they had to make a overbridge here. So, these are the two 4 kilometer things. And of course, they will have the latest equipment because the US detectors are also already, going into advanced thing. And the next picture shows where we stand. Sorry, so I think I have missed out that slide, where the new detectors will now have such events, at least a dozen of them every year. So there could be collapse of stars or various other possibilities. So these were just not possible about 6, 7 years back because the detection was not enough. So now it's a common thing, and the Einstein theory has been proved. And again, this by very look of this, there is civil engineering, electrical. So the actual science from this detector Indian will come much later. You need people to work on these sites. So in fact, IUCA has a set of people who are already assigned to work there. This is about 400 kilometers from Pune in north and east. This is about the space telescope. Aditya is the Indian name for sun. This will be sitting. So this is the sun and Earth system, and some position here, this circle here, there are L1, L2 points where you have minimum movement between the Earth pole, Earth and Sun pole. So they will be placed in these positions, and is supposed to be, again, this is about 1200 crores. This was supposed to be launched, in fact, last year, but because of all this pandemic, it's hoped that this year it will be launched. It's a 400 kilogram satellite. Again, IUCA and other institutes have. So this is the ultraviolet telescope and so on. There are some other pictures. Okay, now coming back to the main topic, how the young students can participate into all this. One is of course amateur astronomy. IUCA has a lot of amateur activity, and other cities and institutes also have. Astronomy projects, telescope making, instrument building, self study, problem solving. This is all one level. And I just wanted to give you uh, a brief, overview of this whole thing. So, what after this talk, basically, you have some idea of what astronomy has in particularly in the next decade, because at our time, all these opportunities were not. So, this is really the golden time for the young students who want to get into this subject, and they have enormous opportunity. You have to just look out for it. Of course, challenge is there like any other subject. You have to be that in the top level, like at least first 4 or 5. Not everybody will go into that. At the same time, if you sustain your interest all the way, these are the things laid out for you. So I will stop here, and I think Prerna can take over some questions. Thank you, everybody.
Yeah, thank you so much, sir, for sharing such great presentation with which have given, I think, many options to the aspirants for working who would love to work in the field of astronomy, and many career options are there. So it was very rightly said that if you love stars and space, so there are endless possibilities in the astronomy and astrophysics. So now we'll open the session for the questions and answer. uh, uh, Rena Bera, in the chat room, you have asked for the slide, so you can write on the planetarium email ID. We can share the slide with you. and along with the poster which sir was telling during the slide. So we'll be happy to share that with you. So you can post a relevant question if you have certain doubt related to the presentation, or you want any clarification on anything. Please feel free to write in the chat box. I'll be highlighting those chats in the screen on the screen, so sir can take those questions from there. Thank you, Mega Rajoria, for joining. So, Nirmal Gupta, which one is better, MSc in astronomy or general MSc?
Okay, so a quick answer to that is, of course, MSc Astronomy is best. But as you already rightly asked, any general MSc you can always, you know, because one thing I should tell you, when you enter a PhD program in any of the institutes, I forgot to mention, there are just like IITs, there is almost 30 institutes who do this joint entrance exam in February all over the country. Many locations are there. There, after that, when you come for interview, we won't ask you astronomy at all. In fact, we will ask you BSc level questions. So your BSc has to be extremely strong. You have good physics and mathematics up to BSc. Only we have seen over last so many years that if the student is, and some students are really smart, they have attended many interviews. The first level of questions, draw a straight line, write an equation. These are the things they answer like a machine gun. Then we really go to a more deeper question like what project they did and so on. So be sure that your BSc level is what you have to be strong. So it doesn't matter whether you do MSc in astronomy or anything. Ultimately in the coursework in these institutes, first year you will be taught all these things. You will be brought to a same level because one university in X place and Y place may not be same level. So make sure that in the first year of course work you all come to one level. Thank you.
Samik, we don't have any course in our BSc physics. We study white dwarf star, highly condensed star, quantum star, and Chandrasekhar mass limit in our statistical mechanism, derivation of these equations. So,
So again, yeah. So this is of course somewhat deeper and technical question. Depends on what kind of subject was taught to you. But as I said, all these things, self study is one thing. There are a lot of books available, and uh, actually, you any of these things, if you have more interest, firstly the students have to do self study, of course, in many things, or else join some of these what you call astronomy courses like summer programs. Of course it is all over India, so we get 500 applications. We can't be sure whether you particularly will be selected, but there are also other institutes offering, not just IUCA, where these kind of things will be covered in lectures.
so again, Nirmal Gupta would like to get clarification, sir. Does Ayuka offer MSc in astronomy?
Okay, good question. So actually, no, till now, and luckily this year onwards, we have already a plan with the Pune University. We will have our own intake. So Pune University typically MSc astronomy. Last 25, 30 years, there were typically about a dozen students. But this year, another dozen will come through this your question. That is, they will be getting into Ayuka's astronomy MSc. So there will be a joint program, which means when they pass out MSc, they will be getting a degree from Pune University, or we also have recognition from JNU Delhi. But yes, I mean, this year onwards, the MSc Astronomy will also start. So you could look for these details in the ICO website.
Rohit Chaudhary, very helpful talk. Can you please shed some more light on career related to instrumentation? Which institute provide these facilities?
Okay, so good question. So majorly all the institutes which I lifted, like Tata Institute, ours, RRI, everyone, because of all these big projects coming up, even other also, they all have instrumentation in astronomy projects. They may not have a telescope. For example, Tata Institute Bombay doesn't have a telescope, but they make excellent instruments for these telescopes. So you go to their website, you will find Professor Oja, who is the main person who has developed instruments for the Unley telescopes and so on. So yes, I mean, not just that, even Ayuka has collaborative instruments with other countries. This Robopole I showed you, they have made telescope instruments for the Greek telescope. So every institution at least astronomy institution has instrumentation program, and some universities also who contribute to the bigger programs.
Veena Menon, good afternoon, sir. I have completed master in physics and wanted to do PhD, but I don't have any experience in astronomy. So will this be a problem in the PhD?
So, as I was telling a little while ago in all these answers, uh, it doesn't matter whether you have a PhD in solid state or it doesn't matter. In fact, just to give an interesting example, one of our earliest students from ICO, they were from engineering background. And today they are excellent. One of them is a director of RRI, Tarun Ghosh. So I should tell you that that is not even a thing to bother. When you want to do a PhD in astronomy, you go through these entrance exams, which I said the joint JEST. You just look for JEST, and it is run by 30 institutes who allow you to do PhD, not just astronomy, other subjects as well. And if for astronomy, you will be going through that test, and then there will be interviews. There are some walk-in winter admissions also where you can walk in, and again you have to go through an interview. Interview is of course the minimum qualification. Typically two interviews in the same institute, and once you qualify, and as I already told you in the interviews, your basic BSc is what will be important. That if you make it thorough, you should not have difficulty. And then of course there are so many institutes, you may not get in one institute, you will try others. And also other institutes take bigger intakes also. For example, TIFR or IIA take more number of students because they have provision, etc. And also when you are getting into the PhD program, even if you have no background of astronomy, you will be taught these things, as I said. So yes, that is not a problem. If you have keen interest, you should pursue them and go to the websites of the institutes.
Samik, what type of skill do I require to get an internship in MSc Physics? Who don't have any background or experience in astrophysics. Seats are quite limited. In YouTube, there are summer courses videos also available.
Yeah, so such things are there. Some of them may be authentic or not. I'm not sure. I've personally not seen them, but essentially, I mean, if you go into my website, Ayukai Arnetin, and you go for my website, there is a list, a book which we published with many other people. It's an IGNU book right now. I think it is available online also. There are some chapters on basic astronomy. So that will answer you many of your basic queries. So when you say internship in MSc Physics, it's not clear because there are many students who have to do projects. All universities have to do the last semester as projects. So it depends. You can take a project even through online or otherwise to any of these institutes. And if the faculty directly write to them, if they are happy, they will give you a project which can be online or you can attend them now. So opportunities are there, yes.
I think it's in the continuation. Are they considerable? So I think he mean if not experience, still a person is considered or not.
Yeah, yeah, yeah. I mean, the experience means what? I already told you your basic experience has to be BS. Rest is all how you will be trained. So if it is a project, I can tell you some BSc students who are doing very complicated theoretical work in astronomy. That doesn't mean that they had a background of astronomy. That's all.
And also, sir, the planetarium do give lots of openings of the post for the educator and the technical helps. So, in
Exactly.
fact, these are also some of the area which students are not aware till the time they see the advertisement or not. So we even in our planetarium, Nehru Planetarium, Delhi, we are about to open most of the post for the educator and for the technical help. So in those we consider MSc, BSc, and PhD will be added advantage. So if they have some project or something, so will be added advantage for them.
Perfect, Prerna. So that is what I actually in my bigger slide it is already mentioned there in one of the corners that planetariums are new opportunities coming up. And as I told you, I think more than 2 or 3 dozen planetariums are already there in the country. And some cities like Calcutta has two of them, Science City as well as the old Birla. And many of these also do night astronomy courses, I should tell you.
Yes, yes.
Yeah. And as you are rightly said, for example, the Patna Planetarium, which I am in the committee, and some others also, we have even strongly recommended that they should have a small telescope at the site for major events, and they should take people from this background. who are already trained in MSc astronomy or BSc, So these opportunities are there. You have to look for it. You may not be, going all the way to PhD, which is, I won't discourage, but yeah, it's a long way for many. But you can do it at BSc level, MSc level. Also get into this line.
Sir, also, I would like to add, because we have a recent experience that one of the fellow in our planetarium, he was from the mechanical engineering background, and because he has an interest in astronomy, he pursued MSc Physics. He got admission in, I think, one of the college in the Gujarat, which who had taken them admitted there. So he pursuing his MSc, and after that he's pursuing his PhD. So he come from an entirely different background, coming from the mechanical engineering and then going to the astronomy field, and now probably he'll be eligible to apply for the educator, even for the director for some of the reputed organization or institute, because he qualify that criteria.
Yes, yes, you are right, Prerna. And I already told that a couple of our PhD students who are right now very well placed, they are originally engineers.
Yes.
So particularly one name which I told, he was a mechanical engineer from IIT Delhi, right there in your city. He was a mechanical engineer from IIT Delhi, and he did excellent cosmology PhD, and today he is way up. He is the director of RRI. So these things. So there is no requirement that you have to have MSc. Basically, only BSc level physics and
Yes.
mathematics
Yeah.
or PhD.
That's right. And also your passion for the subject also matters a lot.
Exactly.
Jyoti Jaiswal,
So again, there is
thank
another
you, sir,
question.
for
Yeah.
such good guidance. Guidance. My question is, we are done with the MSc Electronics and Communication. Then what we can do to enroll in astronomy? Starting point after MSc for astronomy.
Yeah, so the same thing. You see, after MSc, you look for this JEST on the Google. I think this year tests are all done. Next year it is somewhere in February. You appear for that, and you have channels to 30 different institutes, maybe more now. I remember when there were 16, and most of them offer astronomy PhD. So that is the best way. And I should also tell you, just in the universities also, there are my many of my collaborators, they are students. They are of course astronomers themselves, but they are taking astronomy PhD students. They complete their. So, for example, in Assam, two universities, Tezpur and Silchar, there are a couple of students who are done their PhDs under the guidance of my collaborators who are faculty in those universities.
So I think there are a lot many options. Just depend on your interest for the subject and also your passion for the subject, which can give you the more vital area where you can explore as a professionals. So any other questions related to the discussion?
I should also tell you, Prerna, that apart from writing to you or asking this PDF, if they have any specific question, they can always email me. My email ID is, of course, known to you, so you can give it to them.
Sure, 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 sir.
If they have any specific, sometimes they are shy to come online or anything,
Yes, yes.
so
That
so they
that's
can
what
write
that
it.
would happen, because everyone is not familiar to come online or to write question. We completely respect that if they are not willing to come and write, so they can anytime write to the Nehru Planetarium. I'm just posting my email ID in the chat box. It's
Yes,
Planetarium Program.
and anywhere you want me to answer, you just forward it to me.
Sure. So I'm just putting it in the chat room, and anyone who is interested, we can share the presentation as well. And also, if some of the question is related to which you need, sir, to get more clarification on that, I'll be happy to forward and can make a small group in Google or something, so you can have chat there. So we can take the next question. Kshitij, good afternoon, sir. I'm currently doing MSc in physics. Will be a good decision to do MSc in astronomy after completing my MSc in physics, so that I can prepare research paper before PhD in astronomy.
Okay, so this is an interesting question. At least it is off from the general questions people are asking about research paper. I should tell you that now that you are asking this question, see, some of the project students who come because a part of MSc, they have to do a project. You see, I don't know in case of Kshitij what is the situation or where it is, but we have found some very good students who actually even publish a paper in collaboration with the supervisor, which holds a strong thing when they apply for PhD positions and interviews. So yes, I mean, why not? If you are bright enough, sometimes what happens, you may be contributing. Suppose there is a major code writing. I'm just giving an example where you contribute a small part of it, and then you are part of that publication with the supervisor, and your name comes in the what you call the author list, and then yes, that's a big advantage for you. So yeah, I mean that is even better if you can write and publish something. But that is not the only strict criteria. I mean, and also as I said, if you are doing an experimental PhD, don't expect any publication in the first 3 years at least. But yes, if it is theory and if you are doing good, even first 2 years you will get a couple of papers. And I should also tell you that although you know very well that in an art subject you can't have so many publications, or you may not even. So UGC doesn't say that you have to have a publication. But for science subjects, definitely in a university system at least two, and in institutes they need at least demand is more, at least three or four. And when I say good publication, it should be international journal, obviously. So not to say that some Indian journals like Pramana, etc., are also considered to be very high quality. But yeah, I mean, ultimately it has to be refereed, internationally refereed, and so on.
So I think we have more option, lot many option, and the sky is the limit if you want to pursue career in astronomy and astrophysics. And today we have get a more insight and more detailed knowledge about what are the courses and what are the various things one can do if he's interested in astronomy and astrophysics. So I will be happy to collaborate if anyone would like to go ahead. I want to ask anything after the session. So, Planetary will be happy to help. We will be just taking two more questions because just came in the chat box, and then we'll wrap today's session. So, which entrance exam I have to appear in to pursue MSc in astronomy from Pune University?
Okay, so the quick answer is Pune University offers MSc in various subjects. So you just go to the Pune University physics department, and I think you have to appear for some written test. I don't know the latest update. And then there are many what you call options like condensed matter and so on. And astronomy is one of them. So it depends on how good your grades are in that test. And you may give a preference, and there will be the department decides. So the first semester, the first 2 semesters, that is the first year, there is no distinction. After that, you have to go for the option of other subjects. So that is the normal procedure in all other universities also, I'm sure. So there is nothing special to do an MSc. And then somebody has asked about astrobiology. That's a very good question because a lot of new things are happening in. I forgot to mention there was an experiment planned, but because of pandemic it got delayed, or I don't know whether it will be done. We were thinking of looking for astro bacteria in upper atmosphere, and it's a big program and doesn't cost much money, but it's a balloon experiment. But if it is done, it's a Nobel Prize. We will first find even if it's a dead bacteria, it is extraterrestrial. So yes, astrobiology is a new thing, and I think some universities are offering.
Mystery is the name coming on the screen. I have completed BSc Physics in 2017. I want to make a career in astrophysics and astrobiology. So, is there any internship or summer course? Also, I want to do further study, but do I have not knowledge? And in connection to this, he asks, and which entrance exam paper for further studies?
So
Preparation for further
I
studies.
think I don't know whether I can type in the chat box, but anyway, so essentially, JEST is what you have to look for. I should tell you, even BSc final year can appear for JEST. The only condition is they will be pre-selected if they are, and it has happened. Some very bright students, they are yet to complete their MSc, but 2 years before that, they get pre-selected, which means they complete the MSc and they have an assured PhD position opening in an institute. So all these things are there. Just look for JEST. I don't remember the full form. It's like JEE of IIT. You just look, and there will be many institutes. Every year, the location changes, but all over the country there are centers. Somebody is asking data scientist. Yes, that is
Yeah.
enormous demand.
What is the scope of a data scientist in
Yeah, as I
astronomy?
said, with all these huge programs coming up, and you saw one slide on the square kilometer, the petabyte. So that kind of data, firstly managing the data itself is a challenge with newer and newer computers coming, and then how to process it and give a scientific output. But yes, data scientists are required everywhere.
So is it a joint interest screening test,
Correct.
JEST?
Correct. So let them locate it and they will know where to apply and things like that. And after that, they have to appear for interviews in various institutes. And good thing about it is that there is a good understanding between, I think at some point the number is too large, 30 institutes, but they try not to have clashes. And just to tell you, some bright students we have seen, they are like galloping horses. They come from Calcutta, give a entrance test, I mean, what you call interview there. They come to Bangalore, then Pune. I have seen such students, and they are extremely smart at answering the questions. So those are the students where we go deeper, but nothing to discourage you. You should apply and appear. And there are choices. You can give choice of the three institutes and so on. Just go to the JEST website. All the details are there.
Yes, and even so, many organization, many institute also offer summer internship programs like RAD
Yeah.
workshop, also Aries Nainital. I
Yes.
recently know that Aries Nainital, the director Deepankar Banerjee sir has given us the information to circulate that people who are interested to have the Skywatch are invited to come at the Aries Nainital campus. So they'll
Yes.
be giving them hands-on experience for that. So these kind of exposure are given by the institutes, various institute from India. So if students are very much interested, they can make the list of the institute and regularly checking their website for the new update and everything. Every institute had Facebook page, their social media handles, and very
Yes.
active on the website. So you are
Yes.
requested to kindly check those on a regular basis, and whichever suits you, whichever clicks you best, do apply there.
And you see, that's why they are in the golden era. Last 10, 15 years, they have this opportunity. And our time, we had to go word of mouth. There was no internet, nothing. Forget email. So this is the best time they can look for their on their own all these opportunities.
And with this, we'll wrap today's session. This is the last question I think we'll take. What is the procedure for joining any organization as scientist in astronomy after completing BSc?
Yeah, that is tough because at that level, probably the opportunities will be limited because your experience is still not enough. So at BSc level, as a data scientist, there may be some opportunity, just at an entrance level in a computer center or astronomy, but really not much. You have to at least have a data scientist could be anything, it could be at a PhD level, it could be MSc level, but it all depends, what kind of people they are looking for. Yeah, I think
So
they can ask in a different platform now. I think it is already.
yes, so we'll wrap today's discussion, and thank you for joining for today's session and watching your active participation. We really hope that this discussion have given you little insight to where to go in your careers. And thank you, sir. Thank you, Professor Ranjan, for giving your precious time and organizing this session. And in fact, in future also, if anybody wants to ask something, as sir said that he'll be happy to help you, so planetarium will love to collaborate for that, and we can share your questions to sir so that you can get more clarification if anyone is seriously interested to ask something. So I've already posted my email id. It's planetariumprogram at gmail.com, and you can be actively uh, like our Facebook page for all the regular update for planetarium organizing any webinar or workshop in the coming future. Thank you, sir. Thank you. Have a nice day. Take care,
Thank you
everyone.
very much, Prerna, for hosting all this,
Thank you.
and I'm
Thank you so
happy
much.
to answer anything in future. Keep in touch, everybody.
Sure, definitely, definitely, sir. Thank you so
Thank you.
much.
Thank you very much. Bye.
Bye.